Hi guys, welcome back. So in this video, we are being solving this problem from Croto from fluid mechanics. So guys, this is the standard problem from fluid mechanics. So alright guys, before watching the solution, give it a try for 2 to 3 minutes and watch the solution. Alright guys, let's begin the solution. So the question says we have a tube filled with water and closed at the both ends uniformly rotates in a horizontal plane about O-axis. The manometers fixed in the tube wall at a distance R1 and R2 from the rotational axis indicates pressures P1 and P2 respectively. Determine the angular velocity omega of the rotation of the tube, assuming that the density rho W of water is known. So guys, before solving the solution, we have to analyze this picture given. So they have given both pressures P1 and P2 at a distance R1 and R2 from the axis. So the axis is rotated with the angular velocity omega. So we have to find this omega. So we have to solve this problem by using frame of reference here. So by this we can solve this problem easily. So for using frame of reference, we consider a small element of infinitely small length dx of dm mass. So we all know we write dm equals rho w a dx. So this is standard equation. Yeah, equation 1. All right. So for using frame of reference here, so we have to keep an observer on the rotational axis and watch the motion from there. So for a ground observer, for this small element, centripetal force will act inwards. So for this observer, the centrifugal force will act outwards. So basically the pseudo force we have to give to opposite to it. All right. So we have considered that element at a distance x from the axis. So dx is infinitely small, so we ignore it in the equation and we write the free body diagram of dm mass. So yeah, a pressure Pa from leftwards and P plus dP into A from rightwards and pseudo force dm into omega square x from outwards, centrifugal force basically. All right, so we write this in vector form so we can understand it easily. So pressure into a I cap plus dm omega square I cap plus P plus dP into A minus I cap direction equals to 0. All right, so after simplifying this, we get dP into A equals dm times omega square x, and so in the place of omega dm, we substitute rho w a omega square x dx. Alright, the area terms are cancelled here, and we integrate dp from pressure P1 to P2 as in the question they're given. So in the place of integrating x dx from R1 to R2, after solving this, we get omega equals root of 2 into P2 minus P1 by rho W times R2 square minus R1 square. So this is the standard process or standard problem from fluid mechanics. So if you understand this problem, do it a like guys and subscribe our channel. So if you have doubts, comment down below. Yeah, thanks for watching.